Hello everybody, glad to see you. Today we're going to talk about Angularity. As we can see here on this figure, at top left, we are going to control the orientation of this surface with the TZ of 0.3 back to A and B. As we can see, this wavy surface is not in the acceptable area. But by adding the modifier T, it can be acceptable. What does it mean? It means we are going to make an imaginary tangent plane by using three highest point on that surface, and in this way we are going to make that imaginary plane. We can see this imaginary plane is in that zone. It is acceptable. I would like to highlight whenever we are going to use angularity, somehow we are going to control the flatness, but by adding the t, we are going to take care about angle. As we can see in this example, again we have this angularity symbol tz is 2 back to a and b. As we can see at top right in this figure, this wavy surface is not in acceptable area, it is rejected. But by adding the t and making that tangent plane by using three highest point, we can see that red dash point line, it is in acceptable area. Let's see this example. At top left, we have plane A here. It is qualified with flatness 0.25. And plane B on the right hand side is going to control by plane A with a TZ of 0.2. At top right, it is the same, just for surface. On left hand side, we are going to control the orientation of that back to A. At the bottom, we are going to control that plane on left hand side with this angularity symbol. The tz is 0.2 back to A and B. It means at the beginning we are going to control the orientation respect to A, and then we are going to control that orientation respect to B. If we don't have A here, as we can see at top left, we don't have plane A here. It means we are going to control the orientation of this surface respect to plane B. If the orientation of plane B is going to change, the orientation of this plane on left hand side is going to change. It is related just to plane B. That's why it is important somehow to have A and B. First we control respect to A, and then we control respect to B. Here we have a simple example. We are going to control orientation of this surface back to A. We have basic dimension, and in this situation we are going to have two parallel boundaries with a distance of 0.15, and that wavy surface should be in that interval. At the bottom, we are going to control the orientation of this hole. We have diameter symbol here. We are going to have a cylinder with a diameter of 0.2, and the axis of that hole should be in that TZ. In this way, we are going to control the orientation of this hole. Let's see last example for today. We have two parts, part 1 and part 2, and in these surfaces we are going to sit over each other. As you can see at the bottom left, we have this TZ plus minus 2 degrees for this surface. It means we are going to have this situation. As we can see at bottom right, we may not be able to do the assembly based on this wavy surface. You may say, yes, we are going to add flatness. Yes, if we do flatness for this surface, we need to have a tight TZ for that. And if it is not that much tight, what happen? It means we are going to have this situation, as we can see at the top right. We can have these boundaries. If these two surfaces see each other at the top, as we can see in this figure, at bottom left, we may have this gap between these two parts. And also, if we are going to rotate the part 2 and see, we can see at the bottom right hand side, we can see this one. If they see each other at the bottom, again we have the gap between these two. In this situation, it is really good to implement the angularity symbol and control the orientation of these two surfaces. We have TZ 0.2 back to A, and A is qualified. In this way, easily we can do the assembly by not having that much tight TZ. For now, I would like to close this session regarding angularity. In coming session, I'm going to talk about the perpendicularity. Thank you for today. I hope you enjoy it. See you next time.